Hello everyone, I am Adrenaline the Bazooka Prophet. In this particular video, I'm going to be taking you through a journey of quantum chemistry, and under it, we're going to be working on molecular symmetry. It is one aspect of chemistry that is very challenging to students. And I want to use this moment to actually appreciate my prof, Professor Oviawe from the great University of Benin. He has actually done his best to position me in this light to be able to have a wide knowledge about this aspect. Now, when we say a molecule has a symmetry, what we are actually saying is that when that molecule is moved, right? That is when it is rotated, reflected, or even inverted in certain ways, it will still look exactly the same as it were before such movement was carried out. That is it, molecular symmetry. There are some certain things we needed to know under molecular symmetry, and one of which is what we call symmetry operation and symmetry element and groups. So do well to be relaxed while I break it down for you. Now, what is symmetry operation? A symmetry operation can simply be defined as the movement of a body such that when such a movement is carried out on the body, every point of the body will be coincident in equivalent point or perhaps the same as its original orientation. Don't worry, I'm going to make you see it in my own light so that you can visualize it mentally before I give you some certain examples here. But do well to be relaxed. That's the major thing. Again, what is a symmetry element? A symmetry element is a geometrical entity. It can be a plane, right? It can be a point or an axis where two or more symmetry operation is carried out on it. So it means you perform symmetry operation in a symmetry element, right? What then is a group? A group is simply a collection of what now? A collection of elements, symmetry elements that are interrelated. So we are going into it properly. Now take note of these 2 points for those of you preparing for A-level exams. You perform reflection on what? On planes, while you perform rotation on axis. Listen to that carefully. Let us take example as ammonia. Now you and I know that ammonia is NH₃. And if we are to represent it as a symmetry element, we can be having it to be like this. Follow me while I explain to you. If I label here HA, which is the hydrogen here, HA, here HB, here is HC. If this is the original elements, right? We'll take here to be E, which is the identity. All these are identity. We take it to be E. It means that at the end of the day, when it is being rotated, you should get back the original entity. This one does not change. Anything against this one gives us this one. This is the original one. Is that understood now? Just follow me. It's actually not difficult at all. Now, because this molecule here has three axes, it means that it is having 120-degree rotation. For molecules like water, that is like this rotation is 180, like this. So that if I label here, for example, if this molecule is like this, for example, and I label the hydrogen here to be Ha and Hb, when I simply rotate it, it will simply give me like this, Hb and Ha, even when I also reflect it, right? This is 180. In the case of methane, that is CH4, methane is having, if it that's that this is how it is done. 360 divided by what now? By it. For methane, you'll be having 90, meaning the rotation will be 90. But for molecules like ammonia, the rotation will be 120 degree. So let us quickly see how this is drawn and how it works. Now follow me quickly. Now, when this thing rotates anti-clockwise, right, like this, what you will have, follow me, this is what you will have. Look at it. When it rotates, this HC will come here, HA will come here, HB will come here. Normally, when we do all this, we use the ball, but I actually do not have it here in my library here, so that's what I'm using. But you will still get the point. So when this thing rotates here, this one, meaning it will shift. Here will come here. So here I'll be having HC. This one will come here, HA. This one will come here, H what now? HB. When this here we label here C3. Meaning just once rotation here will give me C3. If it rotates again, what I will be having now is simply meaning this one again, we also rotate here. Here will now be HB. Here will be what now? HC. Here will be what now? H what? HA. You know that, so here is called C3 bar or C3 square. Now, what does this simply tell you? Are you aware that anything that will make me to rotate this one again, I will get back this original word identity? That is what we call a symmetry operation. It is the movement of a body, such that when that movement is performed, every point will be equivalent. Every point we coincide in equivalent point, or perhaps the same as it were in the original before it was moved, as you can see here. So what you have just done here is rotation. But in the case of reflection, you use what we call a sigma. This is how it is done. For a sigma, I will teach you many ways here. This is how, meaning you can have 6 operations for an ammonia molecule. Now, for reflection, you will all this first one here, then you reflect it here. So if here is HA, I will reflect it here, become HC, here become HB. This is your sigma 1. Is that understood now? What I will simply do here is simple. I will also hold here, make here constant, right? Like you are putting a mirror here. Here will be reflected here. So here will be, because here is kept constant, here will be HC. Here will come here, here will come here. So here will be HB. Here will be what now? H what now? HA. Is that understood now? You come here, sigma 2. In the case of sigma 3, I'll keep this big constant here. So here becomes like this. So since HB is constant, here will be HC, right? Here will be HC, right? And here will be what now? HA. Is that understood now? As you can see here, we made here constant. We also made here constant. We also made here what now? Constant. As you can see right here on the board. As you can see right here on the board. Just look at how it is moving. Meaning here you just rotate here, right? Then as you rotate here, here is also rotated. So this is how it works. Now, with this operation here, we can work out a mathematical identity, but that will be my next video. For now, go through it again and again, understand the concept, and if there's any problem, you can contact me via my WhatsApp line, where we take and handle all educational matters. Educational matters is our birthright. We are keen in making students to smile and to understand the basics of how questions are coined and to bring out the best in them. Thank you and God bless you.